Hello, Azure Platform Engineering friends, and welcome to a new APE podcast. I am Mark Scholman, and this time I have with me on the show Alex Frankel. In this show, we're going to talk about Azure Platform Engineering with infrastructure as code and Bicep. Alex, welcome to the show. Can you quickly introduce yourself?
Sure, yeah. Thank you for having me. I'm excited to be on the APE podcast. I am the product manager lead for what's called the Azure deployments team. So we're responsible for all the kind of declarative deployment technologies that Azure contributes to. So Bicep and ARM templates. We'll be talking about Bicep today, but also Terraform. I help manage the team that contributes to Terraform. And then also we have an internal deployment service that also uses a lot of declarative technology. So part of my team helps on that internal deployment project as well.
Cool. Wow, that's very awesome. So we're going to talk about Bicep, and let's just dive into some of the content. And I was curious. So why did Microsoft actually invested in creating a Bicep DSL instead? Because we had ARM.
Yeah,
Can you
yeah.
elaborate on that a little bit?
So we were, I guess this is maybe four-ish years ago. We started working on ARM templates before Bicep existed, and we knew ARM templates had a lot of usage. Actually, we helped kind of clarify how much usage ARM templates had. I think it was it didn't have the mind share at that point because they were just not fun to work with or author. Basically, anyone who talked about it complained about it. But despite all that, it had an incredible amount of usage. Just basically every large company and many small organizations were using ARM templates in one form or another. And so we said, hey, this is worth fixing. This is worth making as good as we possibly can. And at that time, there was a VS Code extension for ARM template authoring that was kind of in its infancy. It was kind of a small project. And we said, okay, what can we do there? And we came up the learning curve on languages and language design. We added syntax highlighting to ARM templates, which sounds simple, but it was a whole procedure just to get that implemented. But even that made a big difference because you could actually see the language for the first time. I think ARM templates are written in JSON, but it's actually a language within JSON. There are expressions and variables and all the sorts of languagey things. There was loops and conditions and all this stuff. And it was just, you really had to squint and decipher. It was like looking at the matrix to understand what was actually happening in those files. And so we did a couple things and we did what we could and we tried to make it as good as possible. But we realized relatively quickly that we're going to start seeing diminishing returns really quick. And so what do we want to do with this? What would a step change improvement actually look like? And we did a lot of research. I think it was actually the last, at the time, it was the last in-person Ignite before COVID, where we were kind of shopping around and showing potential code samples of what things could look like. We had a bunch of different prototypes. We had more of a CDK style version of ARM templates where you would author it in a traditional programming language. We had what would become Bicep. And we shopped it around, and we really, honestly, Bicep was we knew going into it that it was going to be an expensive endeavor, and we really wanted to be confident in it if we were going to go for it. And for a variety of reasons, we realized that was, or we believed at the time that it was the right thing to do. We got a really, in the grand scheme of Microsoft, very small team together to kind of put something together. We got a lot of help. We got some language consultation from some of the preeminent language designers that we're lucky to have access to at Microsoft. And we started the project, and it went pretty well right away. People really took to it because if you knew ARM templates, learning Bicep, you could do basically in an hour. You can kind of understand how it worked.
Yep. Exactly. Yeah, that's actually true. So the learning curve for JSON ARM template development was actually pretty high. But once you have gone through those pain, the follow up to Bicep was pretty easy. And so you said you had multiple internal prototyping for DSL, but at that time, there was also the start of Terraform. Was there something also about checking maybe we should leverage Terraform? Maybe we should buy Terraform
We
instead of IBM
yeah, IBM beat us to the
bought it
punch.
now.
I think we definitely asked that question. We said, hey, should we just do Terraform? And really, the decision maker there was really that the ARM templates ecosystem was much bigger. Frankly, there still is a lot more ARM template usage out there, and so we said, to get what is many more people to switch from ARM templates to Terraform and really have a new way of thinking and state files and all those sorts of things.
Yep.
That would be a harder transition than if we can just get people who are already in this ecosystem and just make their life better and just reduce pain as much as possible. We could do that much more efficiently by really refreshing the language. I think I made the mistake of saying, hey, this is a new language, Bicep, yeah, blah, 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 how exciting. But it's the language that already existed. So we made the DSL decision when ARM templates was invented back in, I think, 2014. The second you have expressions in any file, I don't care if it's like a YAML file, like a customized file in the Kubernetes ecosystem, or a JSON file with expressions like an ARM template. It's a one-way door. The second you introduce anything like that, you're now the owners of a programming language, for better or for worse. And with ARM templates, that decision, if you don't understand what you're doing with that decision, you can kind of casually get into it. It's like, oh, well, we'll just introduce parameter support. Oh, we'll just do like a little bit of string manipulation. Oh, we'll do this, that, and the other thing. And you just keep adding and adding and adding until you have something more complex. And if you don't think about it at the beginning, then the tooling and everything around in the ecosystem doesn't really thrive. And so one of the things we really talked about at the beginning with Bicep was hey, the tooling has to be excellent. That's what we need to be thinking about as we're designing the language. So anyway, long story short, we did really look at Terraform closely to say, hey, can this do everything that we need? And can we migrate people easily? But we determined that it was worth it to at least give it a shot to see what we could do with the existing customer base.
Cool. Well, that's at least thoroughly thought about from beginning till end, and also about tooling. If you look at VS Code now, and the tooling that is available there now is pretty awesome and very decent to use nowadays. So if we dive into the Bicep file structures, what is a Bicep file? I mean, just for the listeners who are really new and trying to understand what is Bicep and why should I use it. So we have an ARM template, which is a JSON file. It's a JSON object. You can configure properties and declare actually your deployment. How does this file translate to a Bicep file?
Yeah, so if you know anything about ARM templates, it's really basically one-to-one. So everything you can do in ARM templates, you can do in Bicep. It's just a lot easier. So a Bicep file is its own file type. It's got a .bicep file extension. And the principal thing you're doing is declaring resources. So you're saying, I want a resource, I want a virtual machine, I want it to have this SKU, I want it to look like this. I don't care how you get there. So that's kind of the distinction between declarative code and imperative code, is you're just declaring the what, you're not declaring the how. So you don't need to worry, in particular with Bicep, about sequencing and declaring like an order of operations and checking the status if it exists or not, or anything like that. You just say, here's where I want things to end up. So you can declare any number of resources. There are language functionality that we're used to in other programming languages, like variables and functions and expressions and all of those sorts of things. There are parameters so that when you finish a bicep file, it's a template, it's dynamic, so that you can hand it over to someone, and you can, instead of declaring the SKU and having it be a hard-coded value, the SKU can be a parameter, and you can select from a set of options. And so it's this relatively rigid structure, but with enough kind of dynamism to make it flexible enough for a variety of needs. But it doesn't go so far as like a traditional programming language, where really you can do whatever you want. You can introduce an incredible amount of complexity, which serves its purpose, but in many ways a declarative file like a .tf file in Terraform, or a Bicep file, or a Kubernetes manifest, or a Helm chart, keeping it more on Rails actually has a lot of benefits. So that's a Bicep file in a nutshell.
All right. So if you look at a regular Bicep file that I look at, is you have a parameter section, then you have a resource deployment section, maybe something variables to construct some parameters into something like variables, resource deployments, outputs. And the parameter files, you can, the same again, like ARM template, you can then actually, the same like ARM templates, you can actually, define parameter files in a JSON file. And recently, well, not recently anymore, but I think it's already out for quite a while now, Bicep also introduced bicepparam files. And how can I use that in combination with Bicep file? And why should I use bicepparam over just regular ARM template parameter files? Because from an usability perspective, I would understand that a JSON parameter file is easy to construct, easy to create. It's not that hard, in my opinion. What is the added value of the .bicepparam when I'm defining a parameter file for Bicep?
Yeah, so with Bicep, so with your Bicep file going from ARM template to Bicep, the functionality is the same, but it's just generally much easier to author. So going from ARM template to Bicep, we see about like a 40 to 60% reduction in characters. So just the amount of like noise that is in a JSON file, you're able to reduce that to the absolute essentials in a Bicep file. And that's part of what contributes to what makes Bicep much easier to read than the equivalent ARM template file, as well as author. With the JSON parameters file and the Bicep param file, it's similar, but to your point, it's not as extreme. So the JSON parameters file, there was no expressions, for example. So you couldn't like author a function in a JSON parameter file. So it's actually not a programming language at that point. It's just a JSON file. It's just keys and values. With Bicep param, similar reduction in characters, so it is easier to write and easier to read than the equivalent JSON parameters file. So that's one benefit. The other big benefit is we're able to introduce a lot more kind of language functionality in the Bicep param file. So for one, you're able to validate the connection between your Bicep param file and your Bicep file. So at the top of your parameters file, you can say, there's a using keyword, and you can say using main.bicep, and that creates a connection in the language to validate the values you're putting in a Bicep param parameter. So this is a simplified example. If your parameter is of type string, but your Bicep parameter inputs an integer, we'll catch that prior to deployment. So we're able to do those types of validations, and especially with the introduction of user-defined types and increasing the complexity of working with the type system of Bicep, which I'm sure we'll talk about more, that becomes more and more important. And then the last kind of major benefit is the introduction of more expressions and more functionality. So now you can author a lot of functions in your Bicep param file. So you can do string concatenation and other things that you would have otherwise had to do somewhere else, but that tends to be a nice place to do it. You can read environment variables from a Bicep param file. So before you had to figure out how you wanted to wire an environment variable to get it into your deployment. Now you can do that natively. So you can just declare that I want to read this environment variable as the value for this parameter. So it introduces a lot of capability like that, where you can just get a lot more flexibility in what you're authoring and still get really rich validation and completions.
Interesting. So that's something really valuable. So if we look at also unit testing or pester testing, I don't know what is the proper way forward in the distant future. So how can I know that there are some tooling available for unit testing on Bicep files. How does that compare to bicepparam files? Is that all combining one sort of one functionality set to have a full end-to-end lifecycle management for Bicep modules and deployments, or could that also be with JSON files? So how does unit testing comes to play with this?
I think good testing requires a variety of sets of parameters. Basically, you want to make sure that you're testing all the functionality that you're exposing. And so you could do that with a JSON parameter file, or you could do that with a Bicep parameter file. To each their own. There's no real requirement that you use one or the other for testing. It's really just making sure that you have enough variety in the tests that you're doing. And then there are unit testing frameworks or testing frameworks like you were just mentioning. So Pester, if you're in the PowerShell ecosystem, is kind of the go-to. That's a framework with a lot of history and a lot of support that you can get a lot of functionality out of. There's a kind of a more experimental project out there called Bench Press, which is, of course, a play on words on Bicep. So it's a testing framework specifically for Bicep. They do actually more integration testing, actually. So they will deploy the file for you, and they have specific tests that they've written, and they enable you to write your own tests. And then we actually have an experimental unit testing framework within the Bicep project. So there's an experimental flag that you can opt into if you want to try out the functionality that you can write formal tests in the Bicep language, and we try to make it as easy as possible to test kind of common functionality, both before. Right now, it's just before the deployment, but we also are interested in exploring more integration testing scenarios as well, where we can bring everything up, test it, tear it back down for you really easily. But we don't have any of that functionality today. Right now, we have more unit testing where you can actually do a lot of stuff offline, so to speak. And we're looking into like mocking resource types and other things of that nature, so you can get really fast dev test loops with your tests. So testing is one of those things that's a little more nascent in the infrastructure as code ecosystem. I don't know what your experience is with testing, but everyone's kind of figuring it out on their own. HashiCorp introduced a really nice testing framework for Terraform in the last year or so that enables you to do a lot of things. I'd say that's they're definitely pushing the industry forward on how to do testing of infrastructure code. So everyone's kind of in this experimentation mode. I would suspect in the next year to 2 years, you'll see a lot more kind of testing maturity as Bicep and Terraform developer productivity grows. So some people, I'm really going on and on, but it's like a pet peeve of mine when people who are authoring Bicep code or Terraform code, they're like, I'm not a developer, but whatever. You're a developer. You may not want to be, or you may not like it. You're a developer. The second you're one, writing code, two, checking in code to a code base where other people are contributing to, that's the real mark of a developer, because then you're dealing with all the BS, right? Conflicts and PRs and merges and tests and all that sort of stuff. That's the hard part of development. People can write code, but writing code within a team in a professional setting, that's what makes you a professional developer. And I believe that any Terraform author or Bicep author is a professional developer.
Cool. Yeah, I fully agree with that. So that's actually a nice philosophy about what the developer is, because that's in the heart of what we're doing when we are contributing into a code base, pull request, reviewing. It's all part of that developer ecosystem that we're part of. So
Yeah,
yeah.
and developers in other ecosystems are doing unit testing or doing integration testing. They're doing all of these things, and there's no reason why infra developers shouldn't be doing all the exact same things. It's just the nature of it is different. Like, a lot of times you have to do a full deployment to run a test, which is spinning up resources, and those resources cost money, and that's a different mindset than testing conventional programs where you build it locally, you run it locally, you test it locally, and you've done what you needed to do. You can't really replicate that in the exact same way in the infra world.
Yep. So about infra world and infra deployments, let me continue on the topic of modules, because there's a notion of modules in Bicep. What are they? What can they do for me as an infrastructure developer to work with Bicep?
Yeah, so modules are similar to modules in a lot of other programming languages, are a way to chunk up your code into smaller, more manageable units and integrate them into a larger project. So you can write modules yourself that you use locally in your project, or you can bring in external modules through a registry. But at the end of the day, what it's enabling you to do is take what would have been a very large file that's multi-purpose and doing lots of things, and breaking it up into a set of small files that are much easier to manage and maintain. And maybe you start out by chunking up one part of your code into a module that you only use locally, but you may say to yourself, hey, I'm doing this on every Bicep project that I have. Maybe I'll put this into a central registry. Maybe I'll version it. Maybe I'll introduce unit tests for it and make it a really well-maintained, reliable piece of code that I can use in a lot of different places. Keep my code more dry. It's something that technically you could do with ARM templates. So there was I don't know if you've ever done this in your past, but you could break your ARM template file down into linked templates, and then you could take all those linked templates and put them in a storage account, and then generate a SAS key and reference that SAS key. And a lot of people were doing that, and it was crazy town.
We did it. We did it. We did it uglier. So what we did, we just created resources solutions. So every resource deployment was like a Kubernetes cluster, storage account, key vault was an own NuGet package, versions, and everything like that. And we composed certain solutions, or patterns. If we look at Azure Verified modules, which we also talk about a little bit later in the show, but we package them as like patterns, and then people could pull down like a storage account, key vault, Kubernetes, application gateway, and then have their container platform set up like that. So that's also something what Bicep is actually allowing us to do with modules, right? We can have resource modules like a key vault, application gateway, VNet, Kubernetes cluster, and then compose that all together again in a pattern Bicep file. And if someone doesn't need a key vault, you can take it out and maybe replace it with something else, right? That's the notion of using modules.
Yeah, exactly. And we just that's another one of those things that we just tried to make. Technically, you could do it in ARM templates, but we wanted to make it much easier to do in Bicep. So it feels very natural. Nearly every Bicep project I see has some modules because it's just trivially easy to do. You define parameters, you define outputs, which defines the contract for how you work with the module. And then what happens in the module is a black box. You don't need to worry about it if you're just a consumer. And it just, like you said, makes your life easier. You can have a Key Vault module and rely on it and not have to worry about the details of what it does.
And then if we talk about the black box we should not care about, then I want to talk and introduce the new thing, Azure Verified Modules, which is now something that's where also the Bicep team is working heavily on to have a registry with modules available for us, community and end users of Bicep, which actually allow us to consume modules in a way that Microsoft has a set of best practices. Can you explain a little bit what is Azure Verified Modules and what are the differences of me building my own of utilizing the AVM ones?
Azure Verified Modules is an initiative actually that was kicked off by the technical fields organization within Microsoft. So there's a couple of organizations that are contributing to it. One is the Customer Success Unit, and one is called ISD. The acronym, I'm forgetting what the acronym stands for, but they're two really like ACE teams that understand in an intimate way how these resources should be put together. And so they built up over time a library of modules for ARM templates and for Bicep and for Terraform. And what they did is they really operationalized the contribution and ownership process. So anyone at Microsoft can create and contribute a module to the Azure Verified Module ecosystem. They have a lot of really good guidance on how a module should be put together, how the parameters should look, how the outputs should look, what types of resources should go in what modules. And they have a system of tracking ownership of the module, so you can track health of the module and is it still being maintained and so on and so forth. And the idea is really to have a reliable library of modules for every resource type that needs it. So they do a lot of things. They make the parameters easier to consume. They pick good defaults for a lot of things. They pick good outputs for a lot of things. And so it's really easy. Go
Actually,
ahead.
yeah, so actually on the inputs and the parameters, that what I really like about the AVM modules is that we have like a few sets available also on the readmes, where you have a default set, the minimals, where you can quickly have a quick start, jump start with the minimal set, deploy it against an environment. But what I also really like is the well-architected framework parameter set, because that is really aligning with, in my opinion, how you should deploy it, right?
Yeah.
If you wanna do it according to the best practices, also how Microsoft is actually advertising how cloud should be implemented, then technically I would say, and I don't know if it's true, maybe you can elaborate on it, is you take every resource module, implement it with the WAF, well-architected framework parameters, and you should be good to go.
Yeah, exactly. And what they've done, there have been so many over the years false starts of like, I'm going to build a library of great quote unquote infrastructure code, whether it's ARM templates, Terraform, Bicep, or what have you. And inevitably, what always happens is people stop caring about it. This module is not maintained anymore. And then it just sort of dies on the vine. And in addition to all the great work on the actual content of the actual modules that they're shipping and aligning with well-architected framework and so on, they've built a really sustainable contribution model and ownership model for those modules with versioning and breaking changes and all the things that you would expect. And it's still early, but I've never seen anything be so kind of well run as this project, and I have a very good feeling that it's going to continue to take off and scale up and cover more use cases
Yep.
and take more contributions, and maybe we'll be able to open up external contributions one day. But
I hope
yeah,
so.
but they will take, they'll take PRs. So you can
Yep.
contribute. You just can't be the owner. So we need to find a Microsoft full-time employee to be an owner, just to make sure that those
Yep.
modules are well maintained. But I think what part of what makes it work well is we have a great distribution story with the Bicep registry and the Terraform registry, where we have a great vehicle to ship content and version that content and kind of consume it in a natural way, which we didn't have before. At least in the ARM template ecosystem, we didn't have a good way of distributing code, and now we have a fantastic way of distributing code, which helps a lot.
Yeah, I'm really fan of the AVM initiative. It's like prioritizing Terraform and Bicep deployments from Microsoft best practices. So yeah, and if we can also be part of some resource module development or pattern module development, then if I hear you correctly, then at least we can open up a PR. We need to find some owner in Microsoft, and we can share some more of those modules with the
Yeah,
community. Really
yeah, yeah,
awesome.
yeah.
So if I look at Terraform and the way how Terraform is able to implement providers, like to talk to ARM, but also talk to Azure DevOps, you might feeling where I want to go to. How is Bicep going to support first? If is Bicep ever going to support multiple providers, or is it what's the philosophy behind this provider methodology?
Yeah, I mean, when we started the Bicep project, we said very quickly, like, hey, we're just focused on Azure. We want to make Azure as consumable as possible and easy to use, and for Azure customers to be successful. That philosophy hasn't really changed, but I will say how we think about that statement maybe has evolved a little bit. So to be successful in Azure, you need to do more than deploy Azure resources. You need to set up identities. You need to deploy applications to these workloads, to Kubernetes or web apps or what have you. So you need to set up DevOps pipelines or GitHub Actions or repos and all these other things that really go into actually running a full workload end to end. And so we have started an effort to introduce very targeted providers to enable that journey. So maybe a year ago, maybe a little bit more, we introduced the first provider into Bicep as basically an experiment. So we introduced a provider to deploy Kubernetes manifests to AKS clusters specifically. So you can actually enable a Kubernetes provider and get type support and all the kind of Bicep goodness that you're used to, but for Kubernetes types. So if you're really deep into like the Helm ecosystem, or even beyond that, where
Yeah.
you're doing more complex stuff with your Kubernetes manifests, you might be interested in seeing how that works in Bicep or Terraform for that matter, where you can get more language functionality for doing your kind of day-to-day Kubernetes tasks. But that was really, to be frank, more of an experiment, and we have more to do if we want to enable the Kubernetes ecosystem better. But what we've been doing in the meantime, now that that framework of talking to other APIs exists, is we've been working on a Microsoft Graph or Entra provider. So actually,
Nice.
probably I don't know how quickly your editing is of podcasts, but by the time this goes out or shortly thereafter, the Graph provider will be available in public preview. That's one of the announcements we're doing for builds, where you'll be able to, within
Really cool.
Bicep, create service principals or federated identity credentials and groups and all the things that basically every application kind of needs these days, all in Bicep. And so you can do really cool things like if you have a system assigned identity for a virtual machine, you can, in the same file, put that system assigned identity into a group and assign that group to a specific role. And with all, again, the Bicep goodness, so you can reference properties and get validation and have type support and all that sort of stuff, but now for the graph ecosystem as well. So we're really excited because we think people will really adopt that pretty intensely.
Yep.
And we'll see at that point what other providers that we want to introduce. But there are several on the short list that we think will be valuable.
Azure DevOps,
Yeah,
GitHub.
yeah, those are on the short list. Key Vault is another big one on the short list. They do a lot of stuff in the.
Yep.
We internally say the data plane, so sometimes we'll say the control plane and the data plane. So the control plane is when you're working with ARM APIs directly. And then the data plane is when you're working kind of within the API set of that resource. So Key Vault has a data plane where you manage certificates and secrets and other things that you're not addressing through the ARM API, you're addressing through the Key Vault API. So there's a lot of scenarios like that we think are a good thing to light up in the Azure ecosystem.
Wow, that would be a really welcoming feature to support those things. I think we're almost till the end. I do have one thing on my mind, and that was also that you said earlier, bicep types. We should touch upon that as well. What is it, and I have a mixed feeling about bicep types myself, to be honest, because what I like about a parameter, which is a string, an integer, or it's easy to predict what needs to be go in there. And with types, if I create one parameter storage account configuration, which is a type of all the parameters that I construct that needs to be passed into the resource for storage account creation,
it's more complex.
Challenge me here.
Yeah.
So why should I use it?
Yeah. Great last topic. So Bicep is a type-safe language. So if you get a type wrong, so if you have a parameter that's supposed to be a string and you pass an integer, we'll catch that. And we'll catch that in all sorts of places. So if you're declaring a resource and the properties don't match up with what our understanding is of what the properties need to be, we'll either throw an error or a warning depending on our confidence level. Because sometimes what we understand needs to be input for a resource is not quite accurate for a variety of reasons. So we'll throw a warning for those cases to say, hey, we're pretty sure this is wrong. You might want to double check, that sort of thing. So Bicep is type safe, but we've never turned that power over to our user base. So we built really an incredible amount of functionality to check all sorts of conditions and validate things. And by the way, the error rate for Bicep files versus ARM template files is like 5 times lower because we're able to catch so many things in the editor that we could never catch in ARM templates. So the type safety has been fantastic. And it's one of those things that people don't really even understand most of the time that they're being helped by that, but they are being helped by that quite a bit. But we never turned that power over to the user. We weren't sure if people needed it or wanted it, or maybe, like you said, that's too much complexity. But have you ever declared a mod or defined a module where the parameter was of type object or of type array? When you do that, you've thrown all of that out the window, right? Because we don't know what the structure is of that object. So if you declare an object parameter and then you're going to declare that module and you're filling in the parameters and you get to that object parameter, we just like give you the shrug emoji and say, Godspeed, I hope you picked the right things for that object. With user-defined types, now you can actually declare a schema for that object. And you can say that this parameter requires exactly these properties in this object. Or if you have an array, is it an array of objects? Is it an array of strings? Is it an array of integers? Is it a mixed array of different types? Again, if you were going to input that, we couldn't help you at all with that. And now with user-defined types, you actually can define all of those things, and we can validate them on one side, and we can help you with the authoring on the other. So you can get completions for what's required and what's optional and what has enum values and what doesn't. And it opens up a lot of functionality. It is another layer of complexity, and you may not need it or want it right away, but when you need it, you're going to want it. And we've now made that available to you.
So let me think about an example for this. When I declare a virtual subnet and I have a parameter with defined subnets, which is an array usually. This where I find this could be a perfect example to use this kind of user-defined types where I define my subnet as a user-defined type with all the properties that I need that I will then loop through in my Bicep module or resource deployment section to, define the subnets.
Yep.
Is this
100%. And that sort of thing comes up all the time. And what we've also introduced, it might still be experimental, but we actually allow you to reference a property of a resource. So when you're declaring your type, instead of you essentially like copying over all the different type information for the subnets array, you can say that this parameter is of type resource.properties.subnets, and we can just bring all that information over. So you don't need to be copy and pasting all that kind of stuff over. We can just reference the type information that we already have access to.
And this is really awesome. I'm going to play more with this in the next few weeks because I need to do more with that. I wasn't a fan of it in the beginning, but now I'm
okay.
convinced.
All right, you got the pitch. I'm glad it worked.
Exactly.
A lot of the AVM modules have this pattern in particular. So you see a lot of object and array parameters in AVM. So you'll see them start to consume user-defined types quite a bit. They're a perfect use case for this.
I have one final question, and that is, do you have anything else to bring up that I might miss with asking around Bicep or infrastructure as code that you want to share with us and the audience?
I think the only other one is deployment stacks that I think is very new, but I think will be how most people are deploying infrastructure code, at least Bicep and ARM templates going forward. Have you played around or looked at deployment stacks at all, Mark? You can say no.
Well,
it's
only
okay.
2 times. Yeah, only 2 times because and actually I read something on LinkedIn last week that they're going to implement a new breaking change around deny policies. So I haven't checked what impact it actually has for my current deployment stack. So, but please elaborate.
Yeah, deployment stacks. The big issue with ARM templates and Bicep today is that they're kind of fire and forget. So you can deploy your resources and you can redeploy them and you can update them. But the second you don't want a resource, you're kind of on your own. So we haven't really offered a good way to clean up resources before. And now we do with deployment stacks. So deployment stacks is able to keep track of the resources that are in the stack. And so if you redeploy a stack and there's differences between what was currently managed and what you want to manage going forward, we can say, hey, what do you want to do with this orphaned resource? And you can either detach it and get the stack to stop managing it, or you can outright delete it. So the workflow is if you have 3 storage accounts in your Bicep file and you deploy that as a stack, and then you delete one of those storage accounts and you redeploy the stack, that's when we know, hey, we can delete this for you if you want. It seems like you don't want it anymore. If you're familiar with Terraform update patterns or the Terraform delete or destroy command, it's really replicating a lot of that functionality. So in addition to deleting one resource within a stack, you can also delete the whole stack. So you might have resources across several resource groups where cleaning that up would not be a particularly fun activity. You can now just say stack delete and delete everything with it, clean it up. So it's great for dev test scenarios and for production scenarios. And the best part is that you really don't need to change your workflow. So you use the same file, you have basically the same command structure. You just replace AZ deployment create with AZ stack create. And that's basically all you need to do to onboard.
Yeah, so when you do that, there's also some deny settings and some detach policies or delete policies that you can configure. So can you elaborate on what is now changing with default method of deny actions, because that's something that is now currently, well, at least was shared last week by someone who was a little bit surprised, or it needs some attention for some people who are using it at least. So
yeah,
can you elaborate a little bit what's happening there?
A deny assignment is a special type of role assignment where if you would otherwise have access to a resource either via direct role assignment or via inheritance, which ends up being a common case. So a canonical example is like, I'm a subscription owner because I am deploying an application, but someone set up networking on my behalf, like a central cloud team or someone like yourself might have set up networking. And I'm really not supposed to touch networking. I shouldn't have to touch networking. But because I'm an owner on the subscription, I can do whatever I want to that networking setup.
Exactly.
A deny assignment is a way of removing permissions that I otherwise would have had. So you can put a deny assignment on a particular resource or a particular resource group and kind of section that off and protect it, even though I would have inherited access to it. And so with deployment stacks, what you can do is you can say, okay, put deny assignments on all the resources that you're managing. So the only way that this can be updated is through a deployment stack. That's really good for, like we just talked about, that scenario where you want to section off a set of resources that you want to protect. It's also really good for establishing kind of a single way to manage a resource. So what can happen a lot is someone deploys with a Bicep file and then futzes with it in the portal or futzes with it in the CLI. And then the next time you go and deploy the Bicep file, a lot of things could have changed and you're messing with settings and you're in a mixed mode of management where multiple clients are kind of competing for ownership of that resource. Now with the stack, you can say, I'm deploying this resource with Bicep, and this is the only way that you can manage this resource. And so it enables kind of better practices of resource management as well. And there's no real way around it. So it enforces good behaviors.
Cool. That's really nice. And that doesn't mean that I also have to do the deployment stack deployment then on the management group and targeting the subscription, because otherwise the owner will still be owner also of the deployment stack, right? So you also then, right, should deploy it at least one level higher.
Yeah, so what you can do, there's a setting on the deployment stack where you can say, hey, this file is being deployed to the subscription. So for all intents and purposes, it's a subscription scoped deployment. But I want you to store the stack resource, because it's a resource in Azure, at the management group scope. So if I would have otherwise had ownership access to the stack, I now don't have ownership access to the stack if I'm not supposed to have it.
Exactly. So this is a perfect example where I think that as a landing zone vending machine components comes in, right? Where a central IT organization is deploying landing zones for application teams, and this could be a perfect scenario for them to use this kind of technology. I
Bingo.
believe.
Yeah. So the true like far history of all of our work with ARM templates and Bicep is we started this project called Blueprints, which was exactly for that scenario.
Yeah, I know.
So we built this thing called Blueprints. We said all these central teams are struggling to deploy landing zones or subscription foundations or vending machines. Can we build something to make that easier? And that's where deny assignments actually came in for the first time. But we got a lot of things wrong with Blueprints, and you can think about deployment stacks as the spiritual successor to Blueprints, but it much better aligns with the rest of the infrastructure ecosystem.
Wow. Thanks. I think this brings us to the end of this episode. I would like to thank you very, very much for your time and sharing of your knowledge around infrastructure as code with Bicep. I hope the audience have got all the value that they wanted from this episode, and I would like to thank you for listening to this podcast. If you enjoy our show, please rate and review it on your favorite podcast app, and hope to see you in our next episode.